So imagine yourself being in charge of a large building. Could be a hospital or a school or an office building. Well, I'll just take a hospital as an example. Uh, Amongst other things, people need to know what time it is. And you could just solve that really simply by everybody looking at their watch. But of course, not everybody has a watch. And if it's a hospital, in some cases, you're not allowed to wear anything, on your hands, like jewelry or watches. So that's not a very good solution. Something way more practical is to put up a clock on the wall so people can just look at it and easily see what time it is. It works very well, but if you have a large building, you're gonna have a lot of clocks. The clock, I mean, sure, it keeps time, it works, but it has a few issues. The first thing being that it's running on a battery, and batteries tend to run out after a while. And then someone will need to go and replace the batteries in these clocks. The second problem is that, even though as accurate as quartz movements are today, these things will, they're still made with tolerances. Each movement does differ a little bit from the next movement. And after a while, these differences become apparent. You will have one clock that's running a little slower, another clock that's running a little faster. And after maybe a couple of months, you're gonna notice that you have like a 5 minute difference between the slowest and the fastest clock in the building, and then you need to go and adjust those. The third problem is daylight saving. Well, some countries are planning to do away with it now. Well, European Union, for example, we are having discussions to remove daylight saving, but as for now, that's still a thing. Someone has to go and change the time of these twice a year. If you have, just a few clocks, it's not really a big issue, but if you have a building with, say, 1,000, 2,000 clocks in it, you're gonna have a little problem. So, the solution for that, as electrical clocks develop, was to create one clock that keeps the time for the entire building, and then sends that time over to all the other clocks. And that's called a master clock system. And it addresses all of these three issues. So, the first of all, battery issue. Well, since these clocks run off the power grid, they do not need any batteries. They then use the power from the grid to send a signal to the other clocks. So, those clocks don't need any batteries either. The second thing, since only this clock will actually do the timekeeping, the other clocks will just follow orders, you also eliminate the problem of having differences in what the clocks show. And third, since these clocks come with a few additional features like speeding up or stopping time, you can then easily change the time on all clocks in the building at the same time with a simple push of the button. So that's what a master clock system is. This here, for example, is an electric master clock. It's fully electric, driven by a quartz crystal, just like in the wall clock you saw earlier. The slightly older master clocks, the first one, were actually mechanical. They used a pendulum, which has a swing time of 1 second. That pendulum was then driving a wheel with 120 cogs on it, which made one revolution every 2 minutes, and that then closed. There was a pin on that wheel, and as it went around, it would close a set of contacts on each side of the wheel. So we have one of those master clocks in church in our town, so I'll see if I can maybe make a video about that if time permits, and if I get the chance to talk to them about it. However, today we are looking on a 90's Soviet master clock. This one is ПЧК-3 2RI R24 R61. That's the model for it if you want to follow along, or maybe someone from Russia is watching. They have one of these. Who knows? This one has a few actually additional features that most, I think, master clocks don't have. So we'll look at that too. Uh, Included in the box, you have, besides the clock itself, you have what is, they're called a passport, we call it a certificate. So this one will just, has a name, and then all the specifications and user manuals and so forth for the clock. Inside here, you will even also find basically a certificate and a warranty for the clock, basically saying that the certificate part here is showing that this factory has tested the clock, it works, and it's ready for sale. It has a release date right here, 28th of September 1990, and then where you need to turn to if you have problems with the clock. And then the second part of the manual just repeats everything in English. So considering that, I'm guessing these were meant for export, since I don't really see any other reason for Soviet products to have an English translation. At the end here, we have something interesting. It's a list. First of all, you have a voltage chart here for if you take measurements on the pins here on top, you should be getting these voltages with a normal operation. As well as, if you look further back here, you have a signal chart. So if you connect, if you get an oscilloscope and you probe various points of these clocks, you should be able to get these curves, and this is of course meant for troubleshooting your clock if you want to do repairs on it. Not only that, it has something that you never actually see in products nowadays, full circuit diagrams for the whole clock, and over here you even have like part references and exactly which parts are used, what the specs for the parts are, so if something breaks you can go and get a new one. And here is another circuit diagram. There are, if I recall, 3 circuit boards inside this clock. Another thing included was a bag with fuses, but they seem kind of broken, some of them. I guess they just broke from shipping or something, maybe. And a rechargeable 9-volt battery. Looks like this. Also made in the 90s, so, it's 30 years ago. I don't think this one works, unfortunately. We'll just put that aside. And finally, a note from the manufacturer saying that if the clock has been in prolonged storage, you should have it unboxed for at least a day before powering it on. I'm guessing that is to ventilate out any potential moisture from the clock. So looking at this clock, on front here you have, the display, you have 2 indicator lights, and I'm guessing this has some trim pot in there that you can adjust. On the top you have a little lid that opens to give us access to the various controls for the clock as well as the fuses. And under here, I'm guessing would be the connection terminals. Yeah. On the side here is a little box that you can remove. Right. This is where the 9-volt battery would go into, with some little, I guess, foam to hold it in place, but seems to be somewhat falling apart. On the back, you have the grounding plug and lugs to hold the clock to a wall. So I think let's try and open it up and see what's on the inside. I think we need to remove these 2 screws here on the side. Alright, so with the cover removed, we can now see the exposed inside. So here you have all the switches and the 2 LEDs here for the indication. Here is that trim pot that you should be able to access through the hole in the cover. And then you have the phosphorus display here. I've always loved these types of displays. They look pretty cool. They have this very nice green color to them. And then if we turn it to the side a little bit, you can see, well, as I said, there are 3 circuit boards, and there's like a capacitor, and there are some things in there. And you can also see the terminals here on top. So there's nothing really to look at in here. I guess I could always just say that I've always admired the work that goes into like the cable management and all of these old products. You can see that, you know, it's all tied with this little use a thread to tie the cables together, even for when it's just, you know, 2 wires going to the battery holder. It's still all neatly tied together. So yeah, it's quite a lot of work, I think, that goes into that. I think it's really neat. Well, today we just obviously just use zip ties for something like that. You know, nothing really more to look at in here. I think we can put it back together, and we're gonna plug it in and see if it will turn on. It's never been used, so I hope it works, but then it has been, you know, in rather bad storage conditions, judging by what, you know, its box looked like. Hopefully it's gonna turn on when I plug it in. And hey, look, it does. At least this far. As for the battery, I'll be using a rechargeable 8.4 volt battery. It has the same connector, so it should work just fine for this purpose. Let's plug it in. Looking at the buttons here, it says that you're supposed to push this one when you first turn it on. It's the power indication button, which will turn on a light on the front panel here. It should turn on the left light here. You can see. There you go. The left light is now turned on. The other buttons here, so let's look over them. You have this one that says display off, and pushing it turns off the display. This one here says stop minutes, which I'm guessing when you push this, it will stop sending minute impulses. Then you have fast forward seconds and minutes. Basically what these do is when you push them, it will send additional impulses for seconds and minutes. I don't know how fast it sends them for seconds, but for minutes, with this button pushed down, it will send a minute impulse every 6 seconds. And that is basically to fast forward any connected clocks. Now, these 2 buttons here, they are set minutes and set hours. So what these do is, well, when you push them, they will set the time on the master clock. So this one sets the minutes, and this one sets the hours. These buttons do not actually send any signals out of this clock. They will only set the displayed time. And then right here you have a reset button. What this one does, if you look when I push it, it resets the minutes. Now the way it actually works is when you push it down, it resets them, and when you release it, it starts counting. This is what you do is if you have another clock here with like accurate time, you can see that when this clock reaches, you know, 00 on the hour, you can push this button to set this clock exactly. These 3 buttons here is stop and fast forward 60. These buttons are what you use for daylight saving. So in the winter, for example, when you set the clock backwards an hour, you will just press stop 60 and it will stop sending any impulses out for 1 hour or 60 minutes, therefore the name. And fast forward 60, it will fast forward the clocks by 1 hour. by sending additional impulses. The final button here is memory off. The memory function is the one that remembers for how long there's been a power outage, so it can adjust the time on any secondary clocks. And these three here are simply the fuses for the clock. Up here on the terminals, you have the left two terminals are seconds 1 and seconds 2. This is where you would connect any secondary clocks that require a seconds signal. These two terminals here, you have minute 1 and minute 2. So that's the one you're probably going to be using the most. These are the ones that will send minute signals, minute impulses to the secondary clocks. The third one here is called correction. Not entirely sure what that one is for, but whatever. I haven't fully read the manual yet, so I'll have to see what that one does. Then plus 27 volts and minus 27 volts. This is if you want to run the clock off a 27 volt battery as a backup. What this will mean that if the power goes out, the clock will actually keep running and keep sending signals out. So this 9 volt battery is just to run the internal clock in this master clock. This 27 volts is the reserve power for the whole system, so the system will keep functioning normally. So these three pins here finally, now they are something that I'd say is rather interesting. It's a very, I think, unique feature to Russian clocks. Basically in all Soviet countries you had, and well, many of them still have it, something called the radio transmission grid. What it is basically a physical network of like actual cables. So it's not really radio where you send it via like a radio signal, but it's physical cables that are connecting all the buildings in the city. And you have one main radio station there that will send and broadcast across that network. Then inside every building you'll have a wall outlet where you can connect a speaker and listen to what's being said and what's being broadcasted across this network. Now, every hour you will have a time signal being sent, and it's sent on the hour. So first you would typically have the jingle for the radio station, and afterwards you will have 6 beeps. The beeps are a square 1 kilohertz wave. Each of the first 5 beeps is 1 second apart, and it lasts for 0.1 seconds. The final beep is the time beep, or where the time code is actually sent. That one happens at exactly 00, and it starts off also as a 0.1 second beep, but then for every hour its length increases by 0.1 seconds. And that lets this clock determine, first of all, when to reset the minutes and seconds. So the last beep will have the same function as this reset button. Also, not on this clock, I think, but on more advanced clocks, it will actually even set the time, because, as I said, the last beep is a different length for every single hour. And that's what you connect to these terminals here, and that way you can actually correct this clock. Now, for this particular model, it will only correct if the difference between this displayed time and the time that it receives is less than 8 seconds. So if it's more than 8 seconds, it will actually ignore these signals. Unfortunately, we do not have a signal like that here in Sweden. So instead, what you would need is, maybe somewhere I can find how to imitate that signal here, maybe via an Arduino maybe or something. I'll see. It would be a cool feature to try and get working. So yeah, that's about all I have to say about this clock right now. I'll put it up on the wall later and hook it up to some secondary clocks once I get those ready. That's for now. go down to the comments, put your questions if you have any, and until the next video, have fun and stay safe.